Hey guys, Mr. Gucci. So I did that first video that walked through the first three problems and used a different writing strategy each time to do it. So you choose whatever is good for you. Me, I'm going to choose my favorite, and I am going to just assume that I downloaded or printed this document out and just wrote it in by hand, okay? Because that's going to be the quickest way to show you all this in the next few minutes. So I've worked out 10 sample problems that are very similar to the problems on your homework. And I'm just going to do a few of them right now. Okay, I'm going to do a few of them right now to help you out. All right, I did the first three in the first video, so now I'm going to do numbers 4 through 7, these sample problems. So here I go. Let's take a look at this one right here. Let's figure out the Lewis dot structures for NOH3. Okay, so this is one nitrogen, all right, which is 1, 2, 3, 4, 5 valence electrons. An oxygen, all right, 1, 2, 3, 4, 5, 6 valence electrons. I'm not looking it up at this point. There's only 11 of these elements you're going to deal with. So after a certain amount of time, you just get familiar with it. Maybe have it like on another sheet of paper, okay? So a nitrogen, an oxygen, and 3 hydrogens. So I'm going to do a hydrogen here. I'm going to do a hydrogen here. I'm going to do a hydrogen here. Remember my pro tip, guys. Remember my pro tip, all right? Whichever atoms form the most bonds, you should put those in the middle. All right, so now let me try and start connecting these. Okay, nitrogen and oxygen in the middle because they can make 3 and 2 bonds. I put the hydrogens on the outside because they can only make 1. So here we go. I'm going to try and connect. Okay, so I'll connect this guy here. I'll connect this guy here. I'll connect this dot right there. Well, now we have a problem. I can connect these two guys, but what I've done is I've made 2 separate molecules. I've connected these guys into one molecule, and I've connected these guys into another molecule, and they all need to be connected into one molecule. So that clearly is not going to work. So I'm going to erase this. Okay, so that didn't work. That's why you want to do this with some kind of erasable device. You will make mistakes. You will have to try and redo it. Okay, so let me try another one. I'm going to connect this one here. I'm going to connect this one there. I'm going to connect this here, and I'm going to connect this one right there. Okay, all right, there we go. So it looks like every single unpaired electron has been matched up with another unpaired electron. Everything is connected. There are no more unpaired electrons, okay? And these guys right here, they're called lone pairs. All right, they don't bond. They're fine how they are. Okay, so I'm not done yet. I have to redraw this over here. So I'm going to start with the central atom, this nitrogen here. All right, this nitrogen, and it connected to a hydrogen on its left. So I'm going to put a hydrogen on the left here. It connected with a hydrogen on the bottom. So I'm going to put a hydrogen on the bottom. It connected to this oxygen over here on the right. All right, so I'm going to draw that connection to the oxygen on the right. And this oxygen connected to a hydrogen on the bottom. So I'm going to put a hydrogen down there. Okay, now this oxygen had a pair of dots above and a pair of dots on the side. So I'm going to do 2 pairs of dots. This nitrogen had a pair of dots on top. So I'm going to do a pair of dots on top. And that's it. This is the Lewis dot structure for this molecule. So tips, things that I did. I made sure that those atoms that could form the most bonds, the carbons, the nitrogens, the phosphoruses, all right, those guys were in the middle because they're going to make the most connections. Things like hydrogen, chlorine, iodine only make 1 bond. I put them on the outside. Second thing, I did it in an erasable device. Either I was able to erase whatever digital drawing I was doing, or if I'm doing this on paper, I'm using a pencil. Okay? So there we go. That's that one. All right, now on to the next one. SeCl2. SeCl2. Well, I'm going to go take a look because I'm not familiar with Se all that well. So I made a little valence electron chart. Se right here has 6 valence electrons. So I'm going to do Se 1, 2, 3, 4, 5, 6. And you'll see that this guy is going to form 2 bonds. Okay? It's going to form 2 bonds. All right, next I got to do 2 of these Cls. Now Cl has, let's double check. Cl, now here it is 7. All right, you're just going to be doing the green guys. Right? The green guys are the nonmetals. That's all you're going to be working on right now. So Cl has 7. Chlorine has 7 valence electrons. So here I go. 1, 2, 3, 4, 5, 6, 7. And then I'll do another one down here. All right. 1, 2, 3, 4, 5, 6, 7. Okay, these guys can form one bond each, okay? So now we got to connect these dots. Well, this one's pretty simple, okay? This guy is going to connect to that one. This one's going to connect to that one. There, now every single atom, every single unpaired electron has matched up to another unpaired electron on another atom. So now I'm going to clean this up, okay? So once again, I'm going to start with the central atom, all right, the one that made the most bonds. It connected to a chlorine on the left, so I'm going to connect it to a chlorine on the left. It connected to a chlorine on the bottom, so I'm going to connect to a chlorine on the bottom. And then I'm going to remember to go back and fill in these dots. This chlorine had 3 pairs of dots around it, so I'm going to draw 3 pairs of dots. All right, same with the one down here. All right, 3 pairs of dots. I'm going to draw 3 pairs of dots. All right, and this selenium had 2 pairs of dots. I'm going to draw those in as well. Okay. All right. Now, what you want to avoid is you don't want to put dots on the same side where there is a bond. Okay. The basic reason is because this bond is made of shared electrons. These electrons aren't going to crowd each other when there's some space to place them over here. It just also makes it look neater. Okay. So there we go. That's that one. All right. On to the next one. Okay. The next one is C2F6. So carbons will always go in the middle. They always form the most bonds. Right? A carbon forms, let's see, with 4 valence electrons, a carbon will form 4 bonds. No atom, no non-metal atom forms more bonds than carbon. So carbons are always going to go in the middle. So I'm going to put these 2 carbons in the middle. Okay? Okay. And now I got myself 6 fluorines. Oi, well, I'll draw them. Here I go. This is where if you're using something with copying and pasting would help you out here, okay? But here I go. 1, 2, 3, 4, 5, 6, 7. This fluorine will make 1 bond. All right, and so will every single fluorine. All right, 1, 2, 3, 4, 5, 6, 7. Here's another one. 1, 2, 3. That's a little bit messy. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Each of these guys can form a single bond. Okay, so here we go. Now, you might be tempted to like, oh, I can just connect these fluorines and I can connect these fluorines. Well, once you connect these 2 fluorines, they can't connect to anything else. They become their own unit, and this is a problem because they all have to connect together when you're done. They have to form one single molecule. So we can't connect these fluorines together. Rather, we're going to have to connect them to the carbon. I'm going to connect this guy here. I'm going to connect this guy right here. I'm going to connect this guy right here. Okay? Now, this carbon, if I connect it to another fluorine, it's going to be locked in and it can't connect to the rest of the stuff. So I'm going to have to connect the carbon right here. Okay? This is actually looking a little bit messy. All right, but that's okay. We'll keep going. Then we can go here. Then we can go here. Then we can go here. All right, so there we go. We've done it. Every atom has connected to another atom via that unpaired electron. Okay, so now I got to clean this up. I'm going to start with the carbon. Now, this is a little bit messy here. Like maybe what I might have done instead, I might have connected these 2 carbons at the dots that are closest to each other. So, you know, sometimes if you're done, it doesn't look very neat. Maybe try connecting the dots again. Maybe I connect this guy here, and that guy there, and that guy there, and that guy there. This one here, that one there. All right? You're going to need to clean it up. So I start with the middle atoms. This carbon connects to the other carbon once. So I'm going to connect them once. This carbon connects to a fluorine on top of it. So I'm going to draw a fluorine on top of it. It connects to a fluorine to the left. So I'm going to draw a fluorine to the left. It connects to a fluorine underneath. So I'm going to connect to a fluorine down here. This carbon, same deal, connects to a fluorine underneath, a fluorine to the right, and a fluorine above. Okay? Lastly, and I don't think you're doing this on your worksheet, but I have to respect the fact that each of these fluorines has 3 pairs of electrons around it as well. So I got to write those in. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. That is the Lewis dot structure for dicarbon hexafluoride. Almost done. A few more. Let's chew these. All right, so here we go. Carbon disulfide. Okay, this is an easier one. We're going back to something a little easier. Okay, so carbon, always going to go in the middle because it forms the most bonds. It forms 4 bonds. Okay. Sulfur. Well, how many valence electrons does sulfur have? Let me double check this. All right, sulfur is S. It has 6 valence electrons. So here I go. Sulfur. 1, 2, 3, 4, 5, 6. And another one. 1, 2, 3, 4, 5, 6. You'll notice each of these sulfurs can make 1, 2 bonds. All right. So here we go. Here we go. I'm gonna connect this sulfur to this right here. Okay. I'm gonna connect this sulfur right here. All right. Carbon and sulfur right there. Good. I'm gonna connect these sulfurs together down here. And that means I'd have to connect these guys together, and that doesn't work. You cannot connect 2 electrons on the same atom. All right, so let's erase this. How about this? I'm going to connect this sulfur twice to that carbon, and I'm going to connect this sulfur twice on the other side. You can do that. You can connect 2 atoms more than once. Okay, so here I go. Well, I start with carbon in the middle. Let me clean this up. Carbon in the middle. I connect to the sulfur twice on the right, so I'm going to do 2 lines to that sulfur, representing those 2 bonds. And I connect to 2 sulfurs on the other side, so I'm going to draw 2 lines, and then that sulfur. Okay? And lastly, this sulfur has 2 pairs of electrons around it, so does this one. I have to draw them in. So 1, 2, oopsie. 1, 2, 3, 4. 1, 2, 3, 4. There we go. There we go. That was sulfur or carbon disulfide. All right. Let me try this next one right here. CH3F. Well, once again, carbon, put that carbon in the middle. Okay. So here we go. Carbon in the middle because it's going to form the most bonds. All right. It's going to form 1, 2, 3, 4 bonds. Every unpaired electron around the atom will give you 1 bond. Okay, so now I got 3 hydrogens. Let me draw some hydrogens. Hydrogen, hydrogen, hydrogen. All right, there's 3 hydrogens. And a fluorine, which I drew above. 1, 2, 3, 4, 5, 6, 7. Okay, these guys can each form 1. It's weird that hydrogen and fluorine, despite their different number of valence electrons, can only form 1 bond because each of them only has 1 unpaired electron around the outside. Okay, so now I got to connect these dots. And this, I think you can see, is actually pretty straightforward. That'll go there. This one can go here. It'll go there. It'll go there. Okay? This is actually a pretty easy one. Right? Now I got to clean this up. I start by drawing the central atom, the carbon. And I connected to a hydrogen underneath. So I'm going to do a line to a hydrogen. I connected to a hydrogen on the left. So I'm going to do a line and then a hydrogen. And I connected to a hydrogen on top. So then a line and then a hydrogen. And I connected to a fluorine on the right. So I'm going to go there. All right. Now, got to remember that I have to draw on these unpaired electron or these lone pairs. All right. So here we go. 1, 2, 3, 4, 5, 6. Okay. Not so bad. That one was actually pretty straightforward. 2 more. 2 more here. 2 more practice ones. All right. C2I2. Okay. So once again, we got a carbon. So I'm going to draw those in the middle because they form the most bonds always. So here's 2 carbons. 1, 2, 3, 4. And then another one. 1, 2, 3, 4. Okay, and then we got 2 iodines. What the heck is iodine? Let's take a look. I mean, I know, but let's. Iodine has 7 valence electrons. 7. All right, so here I go. So I'm gonna draw an iodine over here. Oopsie, that's a hydrogen. I'm gonna draw an iodine. You're so slow. Why are you slow? All right. 1, 2, 3, 4, 5, 6, 7, and another one over here. All right, 1, 2, 3, 4, Let's pretend, guys. Let's pretend that I drew this iodine over here. All right, 1, 2, 3, 4, 5, 6, 7. Okay, so these carbons each form 4 bonds. These iodines each form 1. So let's say now I have to match this up. All right, let's see what happens. I'm gonna go through the process of like something that's kind of tricky. All right, so I'll connect this guy to that one. Okay, I'll connect this iodine to this carbon right here. Okay, then I'll connect the dot from these carbons. Okay, but now we have a problem. Okay, because I can't connect two electrons. I can't connect two electrons on the same atom. It just does not work. You're not allowed to do it. All right, so I'm going to undo that. It just doesn't work. Okay, well, this is a problem. This is a problem because who do I attach these guys to? And maybe you're thinking, well, I don't know what to do, Mr. Gucci. This one's tough. All right, this is why you do this with an erasable device. Okay, I'm going to erase this iodine. Okay, I'm going to erase all these bonds. I'm going to draw the iodine over here. 1, 2, 3, 4, 5, 6, 7. Okay, iodine that can make one bond. Well, now let's say, oh, maybe I can connect this carbon to that iodine. Maybe I can connect this carbon to the other iodine. And now look, I can connect these guys. I can connect those guys. And I can connect those ones. There you have it. Every unpaired electron is connected to another unpaired electron on another atom. And it required connecting these carbons 3 times, a triple bond. A triple bond it is called, all right? 3 connections, a total of 6 electrons being shared, 3 being donated by each. They are overlapping. This is the tightest, closest bond. These atoms have to overlap quite a bit in order to share that many electrons. All right, so now let's draw this. I'm going to start by drawing the central atom. It connects to an iodine on the left. Okay? To the right, it connects to a carbon 1, 2, 3 times. So I'm going to draw 3 lines here to connect that other carbon. And that carbon connects to an iodine on the right. Okay? Lastly, got to make sure that these dots are represented here, these lone pairs of electrons. So I'm going to do dots here. I'm not going to do the dots there. I don't want to put the dots on the same side as the bond. It gets crowded. I'm going to just move them over to the other side. Okay? It doesn't matter what side the single electron was on when you started. All right, here we go. There you go. That is this one. All right, that is dicarbon diiodide. All right, last one. Last one. FCP. Mr. Gucci, is that an element? Sounds like some kind of federal agency. The Federal Child Protectors, right? This is probably like what QAnon would call themselves. Good for you guys. Good for you, Q. Yeah, go to hell. All right, so here we go. All right, we are going to do this. Now, once again, there's a carbon. So carbon's going to go in the middle. Here we go. All right, 1, 2, 3, 4. Always put carbons in the middle. They always form the most bonds. Okay. Then we got fluorine, which we've done before, has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay. And then we've got a phosphorus, which we also did on this sheet, which has 1, 2, 3, 4, 5. Now, this fluorine is going to form 1 bond. This carbon's going to form 4 bonds. This phosphorus is going to form 3 bonds. All right, so how are we going to do this? Well, let's say that I connect this fluorine to this phosphorus, and then I connect that carbon to that phosphorus, and then I connect these guys. Well, now I got these guys who cannot connect to each other because they're on the same atom. So that doesn't work. Maybe I connect the fluorine to this carbon. And then now, maybe I connect this carbon and this phosphorus 3 times. This works. Every electron is paired up, every lone unpaired electron is attached to another unpaired electron on another atom. So this works. All right, now let me draw this. All right, let me clean this up. I start with the central atom. I start with that carbon. It's connected to a fluorine on the left. So I'm just going to draw that fluorine on the left. It's connected to this phosphorus on the right. How many times? 1, 2, 3 times. So I'm going to draw 1, 2, 3 lines to represent those 3 connections. All right, a triple bond again. And then I'm just going to write it in. All right, now, last thing, as always, got to make sure that you get these lone pairs in as well. So fluorine had 1, 2, 3, 4, 5, 6. All right, phosphorus just had 2. I'll put them over here. Doesn't really matter. All right, there you go. This is it. You just draw those atoms from the formula, do their Lewis dots, and then connect the single dots. I find this easiest to do on a sheet of paper, then you just take a picture and attach it. All right, maybe you print out the worksheet and you do the drawing on there. That's probably even easier. Okay, just make sure you show your work. Now remember, you have 3 ways you can do this. You can either do the drawings directly in your Google Doc by going to Insert Drawing and then drawing it. You can do a lot of copying and pasting and rearranging to make things easier for you. You can do it on the Jamboard, okay? Or you can do it on a separate sheet that you attach. Anyway, it's up to you. Just show your work. I hope this video helped you guys. I hope you'll email me if you have any questions whatsoever. Good.